Have you ever looked at a piece of code, perhaps a software test written by someone else, and wondered exactly what it was trying to verify? It can sometimes feel like trying to solve a puzzle without all the pieces, or reading a detective novel where the plot jumps around, leaving you guessing at the true intentions of the original author. Well, there is a remarkably simple yet profoundly powerful structure that brings much needed clarity, predictability, and robustness to your software tests. It is called the Arrange-Act-Assert pattern. This pattern provides a universally understood framework for writing effective unit tests, ensuring every test you create has a clear purpose and its intent is immediately obvious. The true genius of the Arrange-Act-Assert pattern lies in its disciplined separation of concerns, meticulously dividing each test into 3 distinct and sequential phases. Each of these phases carries a singular, focused responsibility, making the test's intent and flow instantly apparent to anyone who reads it. The first phase, known as Arrange, is dedicated entirely to setting up the necessary preconditions and preparing all the inputs required for the test. This might involve creating specific objects, initializing variables with particular values, or configuring any external dependencies the code under test relies upon. This meticulous setup ensures that the environment is precisely as expected for the specific scenario you are aiming to test, eliminating ambiguity about the starting state. Next, we move into the act phase, which is typically the shortest but most crucial part. Here, you execute the specific behavior, method, or function that you intend to test. It is the central action that triggers the outcome or change in state you are interested in verifying. Finally comes the assert phase. This is where the rubber meets the road, as you rigorously confirm that the acted-upon behavior produced the precise expected result. This involves checking output values, verifying the updated state of objects, or confirming that certain interactions took place. This structured, 3-part approach is incredibly powerful because it prevents tests from becoming tangled monolithic blocks where setup, execution, and verification steps are all mixed together. Such mixed tests are notoriously difficult to understand, troubleshoot, or maintain effectively over time, leading to brittle test suites. To illustrate this in a practical sense, let us consider how you might test a basic addition function within a calculator application. In the arrange step, you would first instantiate your calculator object and then define the 2 specific numbers you wish to add, perhaps 5 and 3. For the act step, you would then invoke the calculator's add method, passing in those 2 prepared numbers. Finally, in the assert step, you would confidently verify that the result returned by the add method is indeed equal to 8, thereby confirming the correct functionality of your addition logic. Adopting this robust pattern is a crucial and highly effective step towards significantly reducing what software engineers often refer to as test smells. These are undesirable characteristics in test code that make tests hard to read, prone to breaking, or excessively slow. By clearly delineating the setup, execution, and verification responsibilities, you inherently create tests that are not only self-documenting but also remarkably resilient to future code changes. This structured approach offers immense benefits. It isolates potential failures to a very specific phase, often the assert phase, which dramatically speeds up the debugging process. Furthermore, it fosters a clear, shared understanding among development teams, leading to improved collaboration, more consistent test coverage, and ultimately higher overall code quality across your entire project. It elevates testing from merely a necessary chore into an efficient, understandable, and highly productive part of the development lifecycle. Ultimately, the Arrange-Act-Assert pattern is for more than just a mere coding convention. It represents a foundational and indispensable methodology for crafting unit tests that are not only exceptionally effective in catching bugs, but also inherently clear, easily maintainable, and profoundly communicative. By embracing these 3 distinct and logical steps, you empower yourself and your team to build more reliable, trustworthy software with significantly greater confidence, ensuring that your code behaves exactly as intended, consistently, and every single time.
If this helps you fix faster, like, subscribe, and keep debugging with us.